Okay, on Monday, we looked at section 6.1, which we just solved these one-step inequalities by either adding or subtracting. Then on Tuesday, we took those one-step inequalities, we solved them either by multiplying by something or by dividing by something. We said it's same as an equal sign. The only thing we had to do is make sure we flip that inequality sign if we multiply divided by a negative number. Then yesterday, we did the same thing with those first 2 days. We just applied it to what if we had to do more than one step. We solved 2, 3, heaven forbid we even did a 4-step equation or 2, I'm sure. But we applied the same rules. Okay. Today we're going to continue in that trend, but instead of having just one inequality sign or one comparison between numbers, we're going to have compound inequalities. Anyone remember what the word compound tends to mean? What's that, Jack? Yeah, two or more things put together. So we're going to take more than one inequality and see what happens when we compare more than one thing at a time. Okay? And there's two main ways to do that. There's with what's called an AND inequality, so we'll connect an inequalities with the word AND. And inequalities are also, we tend to think of these as between inequalities. And for an AND inequality, x is, what the word is? X must be satisfy both. Must be satisfied. Must satisfy both inequalities. For an AND inequality, it must satisfy both. So we're going to have two or more. We'll have a couple inequalities at once, and it must be true for both, for the AND connector to be true. Okay. We've already seen these things in the past. We saw some compound inequalities in the past when we looked at, we wrote like domain and ranges, if you remember way back. When we looked at domain and ranges, some like functions. We said there were some times where x was between a couple numbers. We generally write these between inequalities as x is, say, between a couple of values. Like, say, I'll even use a variables here, heaven forbid. Like x is between a couple numbers where a and b are two numbers. X is between them. This is an AND inequality. This is the same as writing x is bigger than a and x is less than b. Okay? We almost always write it. We almost always will write our AND inequality as this compound between inequality. We'll almost never write it as x is bigger than a and x is less than b. Almost never will do this. It'll almost always be written as the compound between. Okay? Ors are a little bit nicer, a little bit easier. And they're a little more friendly. Notice that this has to do both. It can't just do one. X can't just be bigger than a. It has to be both in order for this thing to be true. And or is kind of more, let's call it inclusive. It's more kind of friendly. It allows for more possibilities. It's kind of bigger in a sense. Or says that x can be one, the other, or both. Of the inequalities and still be true. And it's generally written like x is bigger than, say, 10, or x is less than, say, some other number, -4. Sure. Make an example. You can tell the difference between an and and or, because you always have to write the word or in order to tell it's an or inequality. Yeah. You know it's an or inequality because I'm going to use the word or. Okay. And this is true if whatever number I pick, as long as I pick some number that fits either one of these two, and we're good. And this compound inequality, this connection, is going to work. It'll be true. Okay? Versus if I only pick one of them, in this case, it's got to fit both. It can't just be. It can't just be one of them. It's got to fit both for it to work. Okay. So we're going to translate this phrase into an inequality. Okay. It says all real numbers. Any real number will represent with a variable. We want to do, and it fit the following, that are less than -1 or greater than or equal to 4. So I want any x that's less than -1 or greater than or equal to 4. Well, any number that's less than -1 or any number that's greater than or equal to 4.
It's not that hard.
No, it's true.
Any number that fits these two things, less than -1, or that same number could be bigger than or equal to 4.
It's not that hard. Just can't do 0, 1, 2, 3.
So I'm going to graph this. What's awesome about OR inequalities is we'll just graph them both on the same number line. So I want to graph this guy. It's an open circle at -1, points to the left. Or maybe x fits this one. X is bigger than or equal to 4. 0, 1, 2, 3. Or maybe x is bigger than or equal to 4. Voila, we've just graphed this compound inequality. It looks kind of scary to begin with. It's really not that bad.
It's not scary.
It's cute.
How about this one? All numbers, so let's kind of fit this in the same way. All numbers that are greater than or equal to -3 and less than 5.
Yeah, it says or.
Yours says or for the second example?
Oh no. Just kidding.
I hope not. Okay, now here's the problem. I said that we almost never write and inequalities with the word and in between. How do they normally look? We generally write them like the between thing. We're generally going to write x between two numbers. Okay, so what numbers is x going to have to be between? 5 and -3. Okay, so we'll write this fun. We've seen this in the past. So if x is between these two, x is going to be between, x is bigger than or equal to -3. Or what if we flip this? What if I put the -3 over here? Which way should this inequality be facing in our compound inequality? Or the x? Okay. I'm going to use that same x to write this one. So what if x is greater than 5? If I use this same x, let's write this inequality. X is less than 5. And we end up with this compound inequality. Notice that the inequality signs are facing in the same direction. The lesser number is on the left, the greater number is on the right. X is between them, and it fits kind of this pattern. We took this, we flipped this one, and then just kind of smushed them into one inequality. Okay. So how am I going to graph this? Well, what values is x in between? -3. Is this going to be open or closed circle? Okay. 2, 1, 0, 1, 2, 3, 4, 5. Circle. Is it open or closed? Okay. It's open. And then how do I represent the numbers that are between these? Good. Okay, a little story problem. Again, we're going to see these live. At an auction, the lowest bid for an autographed trading card is $20. The highest bid is $54. Write and graph a compound inequality that describes the possible bids. It's I don't know, typo. So if I said, oh, I don't know, how about x equals possible bids? Should this be an and inequality or inequality?
Or
And. Why an and? I love it when you say just because I said so, but that's generally not the best reason. What's that? Lowest and highest. What did we say and inequalities are another name for an and inequality? Between inequality. Are the possible bids going to be between 20 and 54? Or are they going to be like outside of those, like higher or lower than those? Be between them. So in our situation, if we're going to pick numbers between two others, we're going to have an and inequality, or a between this inequality. So if x is the possible bids, what numbers does x have to be between? 54 and 20. Could it be equal to either of those two numbers? Yeah, it could be equal to both. So we'll put the inequality sign so they're opening to the right, and they could be equal, so we'll have little bars underneath. If I want to graph this, 20, 54, build in circle, and then our and inequality does what? They go out, right? And inequality, the numbers go out, right? No. They're connected. They're between. The numbers between are connected. Like I said, we're going to try to, whatever we do in the middle, we're going to try to do to both sides. So like, what would I like to do to get x by itself? I'd really like to add 5 to the middle to get rid of this negative 5. So if I add 5 to the middle, then I need to do the same thing to both sides of this inequality. So I'll add 5 to the right, and add 5 to the left. So what do I get? I get an x, and you get 4 plus 5 is 9. 5 plus negative 7, or 5 minus 7 is negative 2. Oh, look, compound inequality. It's an and inequality. Negative 2, 9, open circle, connected.
Oh man, that's just so crazy.
How about a two-step one on the far side? What do I want to do to get y by itself? What's the first thing you'd like to do?
divide by 2
Plus
or minus 4.
Stupid So I'll subtract 4 from both sides, and you get, what, 10 minus 4 is 6. 24 minus 4 is 20. Oh boy, we're not done yet. We're going to have to do 2 things. So now what's left?
Divide by 2.
So whatever I do in the middle, I do to both sides. So what's the compound inequality look like in the end?
3 plus that underneath equal to
10. Alright, so let's graph it. 3, 10. Close circles. And it's a between. So we connect. Okay? So again, if it's a compound and if it's a between or an and inequality, we'll do it to both. And whatever we do in the middle, we do to both sides. When you're done, graph your equation. Or inequality. Ors are a little bit easier. There's not really anything to remember. If there's two inequalities for an or, we'll just solve both of them and graph both of them. So solve this guy, graph it. Solve this guy, graph it. 3x minus 2 is less than negative 11. Add 2. 3x is less than or equal to negative 9.
Oh wait, hold on.
I'll solve this two-step equation.
Wait, is that a 9? No. That, yeah. That isn't it. Okay.
Negative 11 plus 2 is negative 9. Divide both sides by a positive number. So I get Stein stays the same, x less than or equal to negative 3. I'll even go ahead and graph it while I'm at it. X is less than or equal to negative 3.
Oh, I get it.
Or x could hit this thing. So I'll solve this one. Subtract 18. Maybe that's a bad idea. Oh, not bad. 2x is greater than 16 minus 18. It's negative 2. So I divide by 2. X is bigger than negative 2 divided by 2 is negative 1. So I'll graph on the same number line, x is bigger than or equal to negative 1. 3, negative 2. Bigger than negative 1.